Now we can take a look at our TI calculator to actually find that. So to actually find that on my TI, I would say binom and then PDF, because PDF implies that I've got equality. And I'm going to put in here my n, which is 9, and my probability of a success, which is 0.5, and my random variable, which is equal to 2. So that second function, distributions function, I use arrow up to get to binom PDF, and then I put in my 9 trials. And then if I'm using the old operating system, I actually have to put a comma, which is a second function, or which is right above the 7 key. And then I put in the 0.5, and then I actually, if I'm using the old operating system, I would have to put in a comma, and then I would have to put in that my random variable x is equal to 2, and then I'd hit enter. Now if I'm using the new operating system, it asks me the questions that are necessary. What are the number of trials? What's the probability of a success p? And what is your x value? And then you have to scroll down to where it says calculate and hit enter, and it puts this on your computer register on your screen, and then it gives you your probability in just a second after that. So 0.0703 is oops, and then 1, and then it's 2.5, and I'm not going to fit this on here very well, so there we go. So that's the whole value, and this would be approximated by, and Triola likes 3 what he calls significant digits. And I talked about this before, but how you could figure out if I'm doing it right is you could put this in scientific notation. And scientific notation would say that this would be 7.03 times 10 to the negative 3. And there's your 3 digits that Triola wants when you write a probability. So this is 0.0703. That's what Triola would expect you to write there. And so that's your 3 significant digits, as he calls it. So that's what our probability would be. And that's the same thing you get if you computed this longhand using your calculator, or just going longhand and computing it with the formula. That would be crazy, but that's what you would have. Now our next problem says we want at most 3 heads. So we have to translate what does at most mean. So at most, that's the probability that our random variable, the very biggest, so less than or equal to 3. So this is the binomial CDF. So this would be binomial CDF. And then I would have the 9, comma, and then the 0.5 again, and then a comma, and then a 3. And then I would hit enter. So on my calculator, second function, distributions, I'd arrow up to get to binomial CDF. Make sure you use the CDF, because for the less than or equal to, that's what you're using as a CDF, and then 9, and then comma, 0.5, and then comma 3 if I'm using my old operating system, or just putting in 9, enter, 0.5, enter, 3, scroll down to calculate and enter. And then we have 0.25390625 is what my register shows, and this is approximately, and rounding to 3 significant digits, 0.25 and then a 4. And so that would be my probability of 3 or fewer. And so remember, again, when we were taking a look at a distribution function, that would be 3 or 2 or 1 or 0. And that's why that probability is quite a bit larger than this one, which was just one single value. Now the next one here, it has us doing at least 4 heads. So my at least 4 heads, we have probability that x is greater than or equal to 4, and that's the at least, right? The smallest it could be is 4, so 4 or larger. So this one I cannot calculate. This is not on the TI. The only thing that your TI can do is equal to or less than or equal to. So we're going to have to go for a complement on this, and this gets a little bit more complicated because the complement of being greater than or equal to is being strictly less than. Now it's important that you understand what's going on here. So let's just draw a probability histogram here. And let's say that this is our bar 4, right? And then bar 3 would be over here, and bar 2 would be over here, and bar 1 and 0, and so on, right? I'm not drawing these really great because I don't really need that idea. And then we go up here, so 5 and 6 and so on and so forth, right? So da 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 da. So being greater than or equal to 4, that would be this bar and then all of these out here, right? So what's its complement? Well, its complement here is all of this down here. So it's being less than 4, but really what is being less than 4? Well, you see on the histogram here, that's 3 or 2 or 1 or 0. So this is 1 minus the probability that x is less than or equal to 3. So what you have is that some people just gimmick this and say if I need to turn it around, if it's greater than or equal to, then it's less than or equal to x minus 1. So 4 minus 1, which is 3. I don't like to gimmick it like that. I like to really, really think about this. So now to find this probability, I'll do my binomial CDF function. And I put in my 9, and I put in my 0.5 for p, and I put in my 3, and that value is the same one I just had a second ago. So I don't actually have to do it again. I'm just going to do 1 minus, and then I have that probability of being 2, and then 5, and then 3, and then 9. And I'm going to take it out just a little bit further because of round off error, right? So this would be 0.7461, and then I can round that to approximately 0.746, and that would be my probability. All right, now moving on to part G, calculate the probability of getting at least 4 heads in 3 flips of a coin. So, oops, that was G. I'm sorry. This was G. I read G and not F. So that was G. And then F was fewer than 4 flips. So let's go and do the G that I F that accidentally got missed. So this is the probability that X is fewer than. Well, fewer is strictly less than. And that, again, comes right up to here, right? What's fewer than 4? Well, it doesn't start until you clear the 4 bar, which means 3 or 2 or 1 or 0. So this is the probability that x is less than or equal to 3. And we've done that to death, so we'll just put that in 254 approximately when we round it to 3 decimal places. Alrighty, moving on. Let's see if there's